Hello, my name is Marissa Teitelbaum, and I'm a junior in high school. My project is entitled Design of a Novel Pill Container that is more child-resistant and is easily opened by older individuals. The reason I decided to investigate this topic was due to alarming statistics that I found regarding unintentional child overdoses. These accidents occur in children 5 and under roughly 60,000 times a year in the United States alone. Of these overdoses, over 90% of the ones that lead to emergency department visits show that they were caused by caregiver oversight. It is a major issue as children at that age instinctively want to put colorful-looking things, in this case pills, in their mouths. Without knowing the aforementioned statistics, most would assume that the current child-proof pill container is enough. However, this is not the case, and that is why I started my project. In further searching for a pre-existing improvement and solution to this problem, I found that there are currently no Center for Disease Control and Prevention approved improvements for the pill container. That led to my research objective of designing a novel pill container that is more child-resistant and is easily opened by older individuals. In order to reach this goal of creating a child-resistant container, my design would have to abide by the requirement of not being able to be opened by 85% of children under the age of 5 and within 5 minutes. If such a design can be determined to be significantly safer, many people could benefit, as numerous unintentional overdoses could be avoided. My research, or alternate hypothesis, for this experiment was that the novel pill container will take significantly longer for a child to open, or be unopenable, but take a shorter time for an elder to open it compared to a conventional pill container. In doing this experiment, I assumed that no child was previously taught how to open a pill container, and that the household items presented to the children were representative of what could be found on the counter of any standard home. My design was modeled in Autodesk Inventor and then printed on a Sindoh 3D printer for testing purposes. The general description of the design would be a container that is unopenable without the separate key portion that adults would store in a separate location. Here is a video of the final design, and next to it is an exploded presentation view of the 3D model. So this is my novel pill container. It is a simple cylinder with an inset lid, and then the cylinder has parts taken out so that when it is unscrewed with the accompanying key, it can easily be taken out. However, without the key, these parts taken out cannot be used to pry the lid off, nor can the zig-zag design be used to spin it around. However, when you have the fully matching zigzag design, it can easily be used like a screwdriver to unscrew the pill container and access whatever's inside. In order to test this design, I used two groups of human subjects, children and elders. To start, the children, age ranging from 2 to 6 years, with 10 of the 13 being under the age of 5, went through 3 stages of testing. First, they were asked to open a standard pill container that is available at most pharmacies. Second, they were asked to open my novel design without the key or any other items to help them. Third, they were presented with a bin filled with items including a toothbrush, spoon, eraser, button, pencil, ring, hairband, and hair clip, along with the key. During each trial stage, the participant got no more than 5 minutes, and after each attempt, they were asked how difficult it was to open on a scale of 0 being the easiest to 10 being the hardest. The 13 elders, age ranging from 73 to 90 years, went through a similar process. However, they were instructed both visually and verbally on how to open the standard pill container in the first portion and the novel pill container when given the key in the last portion. This was done as in real life, pharmacists would have given them instructions upon receiving the prescription. Here you can see some of the most significant data from the study. For the children, all of the 10 subject trials whose data is not shown resulted in no child being able to open the container in the 5 minutes, leading the data points to be 300 seconds for the time and 10 for the difficulty. The 3 subjects highlighted in the table for the children were ages 3, 4, and 5 years. The 3- and 4-year-olds were able to open the standard pill container, both in under 40 seconds. The 5-year-old, although unable to open the standard container, was able to identify the key and open the novel design. The elder data shows 2 of the fastest participants who could open the standard pill container, along with the 1 who was completely unable to open it. These 2 graphs show that the vast majority of the children, shown in blue, were unable to open any of the containers, and thus found them more difficult to open. In the second graph, it can be seen that the elders found it somewhat more difficult to open the novel container with the key. However, this can likely be explained by their unfamiliarity in opening this type of container and their comfortability with the standard one. I expect the speed in opening the novel container would rapidly improve with a steep learning curve. In terms of data analysis, there was no significant difference in the opening time or the difficulty rating between the pill containers for the children, as all of the p-values yielded a value of more than 0.05. The same was true for the elders. Although all data proved non-significant when compared to the standard design, the novel design was still child-resistant. No child could open the novel container without the key, leading it to be 100% child-resistant. 92.3% of the children could not open the novel container with the key. Of the 10 children under 5 years of age, none could open the novel container with the key. 84.6% of the total children, or 80% of those under 5, could not open the standard container, which actually makes the standard container not child-resistant by definition. In terms of elders being able to open the containers, they were all able to open the novel design when given the key, but even they couldn't figure out a way to open it without the key. In order to improve this design in the future, I would adjust the lid dimensions to ensure it's not a choking hazard for young children. In order to adhere to comments made by the elders during testing, I would add more contrast in the coloration of the different parts of the container for ease of visibility on how the key matches with the lid. Another improvement would be to increase the diameter of the pill container in order to not only better represent the standard pill container dimensions, but to also make it more difficult for smaller hands to grasp. The following are commonly asked questions that I have encountered during this research project. To start, what happens if you lose the key? Every time someone gets a prescription from the pharmacy in this pill container, they would get another key. Therefore, as time goes on, each household will have multiple identical keys to use in the event that they lose the one that came with that specific prescription. Additionally, if this is the first prescription with this type of container that the patient got, they could simply go to the pharmacy to get a new key, or ask their neighbor if it is either an emergency or if the pharmacy is closed. Next, the biggest issue during the design of the container was making sure that all of the components were able to fit together and function properly in their respective applications. Of the different parts, the most difficult to create were the threads on the lid, as their design and the key could not interfere with the threads, and also, in general, the threads were difficult to print properly. And the biggest issue during testing was that with the elders, it was hard to get them to tell me their actual age, as many were not willing to admit how old they were when I asked them. For the children, the most difficult task was making sure that they understood what I was asking them to do, and that they didn't get distracted between trials. Finally, the zigzag design was chosen so as to eliminate the chance that a household item would be able to open it, as that shape is not commonly found. Additionally, the width of the design was made to be wide enough that a common knife would have a hard time opening it as well, since it was too wide to easily get leverage from both sides. Thank you so much for taking the time to listen to my presentation.